Welcome back to our adventures in Advent of Code. I have been labeling these YouTube videos as for beginners, partly because I thought I would be doing a service of trying to make these puzzles more easy for newer computer programmers to get into this. But the thing is, I'm not exactly an expert myself. And as you can see on the left side of the screen, I'll admit, and I'll say this a few times through the video, I did not solve part 2 of this puzzle by myself, and I'll try to walk through everything. What happened earlier tonight was that part 1 of the puzzle I solved in about 10 minutes, and that's still on the slow side, by the way. It was a very easy thing to do. And then for part 2, it was computationally intensive, and I tried to come up with a clever mathematical formula to solve it. And the thing is, once the video and the recording got to be about an hour long, it was not really of any value. So then I saw what what other data scientists were doing, and really liked their ideas. And I hope no one minds that I'm just going to quickly try to redo everything, type up solutions, and explain things along the way. If anything else, this will probably create a nice short, let's say 20-minute video. Alright, for the puzzle itself, day 6, lanternfish. Basically, you're in the submarine and you're surrounded by these fish, and out of curiosity, you want to get a sense of how many fish are there. Now, these lanternfish reproduce every 7 days, so produces, let's say, I'm going to say reproduces, but produces a new fish every 7 days. Every time a new fish is created, there's also a couple days where the fish is kind of a baby fish. And what will be asked is, say, after 80 days, how many fish are there? In the example, we have 5 fish with these timers. So the first fish will reproduce after 3 days, the second fish will reproduce after 4 days, 3, 1, and 2. When a counter reaches 0, for one thing, it will be reset to 6 the next day. 1 day of the 7 days has gone by already. And when the counter reaches 0, we will also produce a new fish whose counter will start at 8. So we could roughly see that we have an exponential growth pattern. As stated in the example, each day a 0 becomes a 6 and adds a new 8 to the end of the list, while each other number decreases by 1 if it was present at the start of the day. So let's go ahead and code this up. I'm going to create an R Markdown file. Now I'm going to also type in the inputs directly into this file. And we'll bring in the documentation. So the puzzle input, that is the timers for the fish that we're dealing with today, at least for me, was this long list of numbers here. I'm going to bring this into R, notice the lowercase c, to combine or concatenate the information, like so. Now, like what we've been doing for the past few days, we're going to do this and try these calculations on the smaller example first. Make sure this works before running this on the larger input. So now we're going to try to bring in these ideas where we're decreasing the counts by 1. For every 0, make a 6. For every 0, add an 8 to the end of the list. I'm going to call what we're looking at literally current day and next day. The example starts off on an 18-day time span. So we'll call total time 18 for now. And because we're working in time, I'm going to use t as my counter variable. First, we're going to reduce each timer by 1. And I'm going to call this next day. Next, we're going to reset timers that got to 0. So at the locations where current day was 0, rather than reporting a -1, the next number down, we're going to reset these numbers to 6. And then finally, generate the new fish too. So the number of fish that we produced was where the current day was 0, and we're going to literally find the number of those locations. We're going to attach to next day the number 8 and keep attaching the number 8 for the number of reproduced fish. And then finally, if everything goes well, we could then update our information that the current day is the next day, or, we progress in time. So what I'm looking at is after T amount of days, there are that many lanternfish. So now our program produces, as in the example, after 18 days, there are a total of 26 lanternfish. If I now change the time to 80 up here, after 80 days, there are 5,934. And then what I did in my earlier attempt was then I simply turned off the example puzzle input, put in the real puzzle input, and ran the code to solve part 1. At this moment, what I have is literally a vector of about 6,000 numbers long. In part 2, the puzzle makers get creative, perhaps a bit sadistic, and they ask you to extend the amount of time out to 256 days. Now, I immediately realized my computer would not be able to handle that with the code set up as such, because the vector would keep getting longer and longer, and whether it's the space or literally just the time to check all the numbers, the computer would not be able to handle that in a reasonable amount of time. These advent of code puzzles, even for an average computer, should be in a situation where you could compute it within, say, 5 minutes. So, what I did in my earlier stream is I literally just sat around for an hour trying to come up with a mathematical way of solving this, because as a math teacher, I have taught exponential growth in the past, and I thought, I could just find a clever formula to do it. Alas, I did not. So instead, we're going to try to be even more clever than that. Looking over my previous notes. Okay, so this time around, let me see if I can pull up the console. Remember, the puzzle input were these days here, or these counters. So after I went on Twitter, realized what the more clever data scientists were doing. They were keeping track of just how many times the numbers appeared, called counts or frequencies. Obviously, those are different words, but for our purposes, they're the same goal here. So what we wanted now is to note that there's one fish with a count with a counter 1. There's one fish with a counter of 2. There are 2 fish with a count of 3, and 1 fish with a count of 4. So we could use the table command to do that and get what I just said. The issue is that when we look at these example numbers, we know that other numbers can appear, namely 0, 1, 2, 3, all the way up to 8. So now the function that I was not really aware of is called tabulate. And with the parameter where you could tell R how many categories there are, this is called number of bins, as you can see there in the bottom left, you could create spaces, literally counted off how many 1s there were, how many 2s there were, how many 3s, 4s, 5, 6, 7, 8. And then finally, we need a way to, because the numbers can be 0, we need a way to keep track of those as well. So what happens is that the current day has a more complicated code where we are going to keep track of how many times each number appears definitely for 1 through 8, and also leave a space to be able to count zeros as well. So I could show you what's going on. I'm going to create an ID variable, and like I've did in previous videos, I'm going to make a data frame of this. So now, here on the top left, at the very start, we have that one fish was a counter of 1, that one fish was a counter of 2, the 2 fish was a count of 3, and the 4 fish was a count of 4. But we realize that we'll be able now to place fish with the other possibilities as well. I want my total time. We'll start off with 18 days. This time around, the number of fish that are reproducing is in the first spot of current day. The number of fish reproducing is in this top right spot of the current day. From there, this is the clever trick right here. To subtract 1 from each counter, we're going to actually move the numbers in the data frame itself. So the next day, let me create a space for that. So what I'm doing is in my data frame, I'm creating space to keep track of what's happening in the next day, just like what we did with part 1 of the solution. And the clever trick is to move these numbers, particularly the 1121, and move them up in the data frame. So now, if you're looking at the 1121, do you see what happened? So that is actually one of the more powerful aspects of this particular approach at solving a problem. The rest is of filling out the instructions from the task at hand. First of all, we restart timers that had reached 0 to 6. Now, because notice the count ID in the top left, because I'm starting from 0, the 6 is actually in the 7th row. And there is a possibility in the long term that there are numbers there already. So we take what was there already and add the number of fish that are reproducing. Also, according to the puzzle instructions, for the new fish, because they're baby fish and they'll take a little bit longer to reach the time when they can reproduce, we'll start their timers at 8. The 8 appears in the 9th row, like so. And then finally, the update works pretty much like what we had in part 1. So now when I run this code, the numbers will keep increasing a bit, but otherwise, because we had kept track of the counts, when we want to get a sense of how many fish there are, we simply now need to add up the numbers in that, let's say, the second column. So after that amount of days, there are adding up the numbers in the column, and then lanternfish. So now, after 18 days, there are still the 26 lanternfish. I could kick that up to 80 days and get the 5,934. And then finally, for the real puzzle, I would once again toggle off the example and use the puzzle input. So before I forget, I want to give credit where credit is due. What I did there is follow a solution that was made by this data scientist, and I apologize, I might not pronounce their name correctly, Emil Wittfeldt. And I'll post a link to their solution. Oh, and for good code. What we were doing was simply keeping track of how many times the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8 appear, rather than it keep expanding the vector. Alright. So yeah, that was a tougher puzzle, and I wish I could have solved it myself, but I did not. But hopefully, if for those who are following along with the videos, I explained most of the code in a way that makes sense to you. Alright, folks, we'll see what day 7 has in store for us tomorrow. See you then.